Hi everybody, welcome to another video in this quiz math section 9.1 relations and their properties. In this section we study about the properties binary relation, the binary by mean 2. So there will be a relation from a set A to a set B given by R. So here's some example. Let A be 0.0, 1 and 2, B is A and B. Then we define 0 to A, 0 to B, 1 to A, and 2 to B. It's a relation from A to B. And we can represent by the graph or by this relation chart or relation table here. Right, so binary relation on the set A, the subset of the Cartesian product of A and B, or a relation from A to A. Right, here is another example. Right. Now, go to the question, how many relations are there on the set A? So, because the relation on A the same as a subset of A, Cartesian product of A and A, we count the subset of A by A, which is n squared. And the set of m elements has 2 to the m subset. So therefore, the subset of this Cartesian product A times A is going to be 2 to the n minus 2. Yeah, remember, if the set has m element, it will be 2 to the m. It has n square element, it will have 2 to the n square relation with n elements. Right. Now we talk about the properties of a relation. So the first one is reflexive. It says that every element relates to itself. Right. Here we have some example. Oh, by the way, all the relation with the subscript number will be the same throughout this section. Right, so A and B, if A is less than or equal to B, well, this makes sense because A is indeed less than or equal to A, so itself relate, any element relate to itself, so that's good. Next, A is equal to B or A equal to negative B. Either way, if A equal to A is equal to A, and when we have A is equal to negative A, then negative A is equal to A, of course. So that check as well. Of course, A equal to B, of course, this should be lowercase a. That by definition, an element is equal to itself, so that's good. Next, these are not reflexive, because when you write 8 greater than 8, that false. And A equal to A plus 1, that also false. And A plus B less than or equal to 3, that is not true for some case. For example, 2 plus 2 is not less than or equal to 3, so that also false. Here we focus on the integers. A and B are integers, so this will be false in any of this. So that's why this is not reflexive, and those relations are. Right, next we have symmetric. Symmetric is if x relate to y, then y relate to x. Here we have some example here. If A equal to B, then A equal to negative B. Of course, if A equal to B, then B equal to A. That makes sense. And if A equal to negative B, then negative A equal to B. That's also true. So that's one's good. Of course, equal is reflexive, is symmetric. A equal to B, then B equal to A. That makes sense. A plus B less than or equal to 3. For example, 1 plus 1 is less than or equal to 2. To 3, so it's good. And 1 plus 2 implies 2 plus 1. Yeah, so all of this check. Now, these are not symmetric, because when we say A, I just give some example here on the integers. 2 less than or equal to 3 implies 3 less than or equal to 2. That's why this is false for sure. Same thing for greater than. For the next one. Okay. If I write that is true. Three greater than 2 imply 2 greater than 3. This is false. And the last one is also false. If we have 3 equal to 2 plus 1, doesn't mean 2 is equal to 3 plus 1. So all of that are false. Right, so that is symmetric. Now we have anti-symmetric. Is that a relation is anti-symmetric is if A relate to B and B relate to A, then A and B are the same. Right, now this is a little bit more difficult. Now, if we have A less than equal to B and B less than equal to A, then A is equal to B. Now this makes sense. The only case that equal, so that could be less than and greater than at the same time. Right. And then if A greater than B and B greater than 8. Right, as I said, we don't have any of those numbers. The answer is true. If A is different than B, if this satisfies, that could be a problem. So if this satisfies, we have an empty set. Nothing that satisfies these properties. Because so in that case, if it is an empty set, it satisfies any properties. Right? Because it's an empty set, we cannot conclude anything to that. But like I said, just like saying that if Superman exists, then something happened. Of course, Superman does not exist, then something happened or not doesn't really matter, because false implies true is true. So we don't start with something false. This is false. So we don't have to worry about anything. Of course, if they are equal, then A equal to B. Yeah, that's true. And now the next one, same thing. A equal to B plus 1 and B equal to A plus 1. This is give us no solution. And that, of course, something false implies true is true. I should say false instead of an empty set. Right, next, the following not. I forgot not. If A equal to B, then B equal to A, but A equal to negative B and B equal to negative A is not equal to B, so that's not the case. Same thing, A plus B. Okay. Yeah. Of course, 1 plus 2 less than equal to 3, 2 plus 1 less than equal to 3, but 2 are not equal to 1. So that's one false. Yeah. This one obvious, because if A equal to negative B, B equal to negative A, they're not quite the same. That means there's 0, 0. Yeah. That might not be the case. Right. Now we have transitive. Now this is easier. Transitive meaning if X relate to Y, Y relate to Z. So X to Y, Y to Z, then X to Z. That's the relation. The following relation on the integers are transitive. Right. So A less than equal to B. So A less than equal to B, B less than equal to C imply A less than equal to C. Yeah, that's obviously true. Same thing for greater than. Equal or opposite, that equal to opposite. Those obvious and equal. So those this next two are obvious. If A equal to B, B equal to C, then A equal to C. Right. The following relations are not transitive. A equal to B plus 1. Alright. If A equal to B plus 1 and B is equal to C plus 1, so A equal to C plus 1, substitute in B, C plus 1 plus 1, so C plus 2. So A and C are not related. Next, A plus B less than or equal to 3. 1 plus 2 less than or equal to 3, and 2 plus 1. I should write that backward. One plus 2 less than 3, and 2 plus, I wrote the same thing, 2 plus 1 less than 3, and 1 plus 2 less than or equal to 3. Does that imply 2 plus 2 less than or equal to 3? That's what the transitive property would be, right? So that false. Next we have combining relation. So we just like the relation is just a set of pairs, of order pairs. So we can do the union, intersection, difference, and everything else. If R1 is this, R2 is this, what is the union? Of course the union, we're just going to list everything. 1, 1, 2, 2, 3, 3. Already have 1, 1, now 1, 2, 1, 3, and 1, 4. The intersection is the one that have common. That will be 1 and 1. The difference in 1 but not in 2. So in here but not in here. So that will be 2 and 2 and 3 and 3. And R2 minus R1, so in here but not there. So they have the 1, 1 in common. Other than that, these 3 in R2 but not in R1. So just like what we did before with the operation on sets. Next we define a composition or the composite of a relation to a relation. So pretty much we go from R1 to R2. Yeah, so R1 first and then R2. So I think this is backward. So we go from R1 and then R2. Actually this is correct. So R1 first, R2, so that we write like this. Remember, this is R2, just like function, we would write like that. So R2 inside first, on the right first. So we go R1 and then R2. So that makes sense. Now with that, we can define the power of a relation is given by just multiply by itself. But in this case, instead of multiply, we do the composition. And finally, there's the theorem. The relation on the set A is transitive if and only if R to the n is a subset of R. Alright, just going to leave it that theorem, and that's all I want to cover in this section. So most important is all those properties: reflexive, symmetric, antisymmetric, and transitive. So those properties, make sure you know those. We finish this section here. As always, thank you for watching and see you in another video in Discrete Math.